So we're on 3B.2, part 2 notes. This should be page 110, correct? Okay, so we're on page 110. You're going to divide into 3 parts horizontally. So section it off into 3 parts horizontally, meaning that you have 1 section, 2 section. You can make these sections as we go through the notes. You don't have to make them right away, whichever way is your easiest and preferred method. All right, so there are some specials, some special perfect squares. Do y'all remember? Don't write this down. Do y'all remember what your perfect squares are? Like numbers that are perfect square. No? So we got 4, we got 16, 49, 64. Are we ringing some bells now? Okay, your perfect squares are your numbers that you are multiplying times itself, right? Factors are the same. So 1 times 1 is 1. That's a perfect square. 2 times 2 is 4. That's a perfect square. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. Ringing some bells now? Those are your perfect squares. Anytime that you see a problem made up of these perfect squares, there's a special shortcut that you can take to factor them. Does that make sense? Okay, so that's what we're going to be focusing on this page. So it's called method number 5, perfect square trinomials. So when you have a perfect square trinomial, what it looks like is that your A and your AB are, your A and your B are perfect squares. So whether it's squared variables or squared number, they are perfect squares. So the first thing you're going to write down is the rule for perfect square trinomials. And this is the rule for your perfect square trinomial. I'll give you a moment to write them down. Okay, so now we have all written it down, so we're going to use the rule. So at first, we have, you're going to write down 4x squared plus 24x plus 36. And it wants us to factor it. So you're like, this number looks interesting. What makes this number look interesting is that its A term is 4x squared, 24x, 36. Its A term and its B term are both perfect squares. 4x squared is a perfect square, and C equals 36 is a perfect square. So based on this rule, instead of having to go through grouping or go through Xbox or any of that, it's simply saying that if you take the square root of your A term and the square root of your C term and multiply them together, it makes your B term, right? So you just double check that that's true, and then you just have to you can factor it as A plus B. So the square root, that came out ugly. Let's try that again. So what is the square root of 4x squared? 2x. What is the square root of 36? 6, right? And if you double them, does it equal 24x? Yes, it does. So because this checks out, that means that instead of having to do CAB, Xbox, grouping, flip, whatever your teacher has taught you, you can then just simply write it as a sum of its squares. So the factor of this is simply, what was the square root of your A? The square root of my A is 2x plus the square root of my B, which is 6, and square them. And that is your factor. Can you see that? Okay, so again, as long as that works, then you're good. Otherwise, you would have to factor out the GCF and do the whole shebang, but you wouldn't necessarily have to if you can simply do this. right? Okay, how do we feel? Doable? Okay, now to add on to this, there is a GCF. And because I didn't factor out in the beginning, I can factor it out now. Does that make sense? The GCF is what? Well, now what's the GCF? 2. My GCF now is 2. So if I factor out 2, it's not just 2, but I have to factor out 2 what? Squared. So when I factor out 2, I'm left with x plus 3 squared. So fully factored, this would be 4 times x plus 3 squared. So this is fully factored. Nothing else can be taken out. Nothing else can be removed. So you either can take the GCF out in the beginning, or you can take the GCF out once you factor. The thing is, if you take it after you've used the perfect trinomial square, you have to make sure you square the GCF. Do we see the extension? Okay. All right. Let's try it again. So on this one, our A term is 64x squared. Our B term is negative 16x. And our C term is 1. Just to emphasize, A is a perfect square and C is a perfect square. Because they are perfect squares, I can say, okay, let me check its square root rule. So I need to know if this equals double the product of these two, right? So let's see. The square root of 64, x squared is what? At 8x. Obviously, the square root of 1 is 1. Does 2 times 8x equal 16x? The answer is yes, it does. Now, because of this, the negative right here lets me know that instead of using the plus rule, I'm using the minus. Does that make sense? So my factors of this become 8x minus 1. If this shortcut doesn't work for you, you can always use grouping in Xbox and it's still going to get you to the same thing. Does that make sense? This is just someone realized the pattern, was like, oh my gosh, this is so much easier if we just do this. And that's where you came into your perfect square triangle. Okay. Again, it's just a shortcut. Do you have to use it? No, you do not. Okay. All right.